For what? Oh, I don't know. Ask Google.
Okay, Google, how much longer? Okay, Google, how much longer?
Hi guys. You all?
Hello.
Good day, guys.
Hi, guys.
Hello.
Hello.
Hey Mateus. How are you, man? Where's your hat, Tim?
Let me see if I can find it under the table somewhere.
Like I will have the same background.
Oh, nice. Good one. That's the best one.
Yeah, it's the best one. Can you see this mirrored or is regular?
No, it's normal. Yeah.
Ah, it's normal. Cool.
There you go, mate. Much better.
How did you guys go with the exercise during the week? Still have a few minutes to go.
In my case, was good. I like those exercises, and I thought it was easier than the class 2 exercise.
You didn't like much the networking ones?
It's too much better. Networking is the worst part on IT, I think. I came from network, but now with cloud, I think network is massive.
Yeah, last time I've seen networking probably was when I was 16, 17. From that, only setting up my Wi-Fi router, and that's it.
It's still the main call that issues. One of the networking units, so it's good to know, so we can troubleshoot and fix.
Your microphone is,
Yeah.
I don't know what's going on.
It's too loud, your microphone.
It's like a monster.
Hopefully it's better now.
A little bit.
Too loud?
Very loud, yeah.
Wow.
But it's better than before. I'm just going through here your feedbacks. Thanks for providing quite a lot of information. We probably won't have time to cover all of that here. First question here is on the ASGs, minimum maximum desire, for Zara asked. Essentially, the ASG will keep the desired number as much as possible. The minimum one is few use cases if instance crashes, or with AWS, sometimes you have some limits on the instance that you can spin up on a availability zone. And you might try to create an instance and get an error saying that is the limit for that AZ. I've seen that happening sometimes. So that could impact not having the desired number on your ASG in one point in time. What other use case for that? But it's pretty stable. Like if your application is running fine, you most likely will run on the desired number most of the time. What else? Is Alan already connected? Not yet. Gustavo mentioned here that it's spending too much time to solve an exercise. Yeah, if you spend more than a couple of hours and you are not making more progress, that it's a good indication that you should ask. Don't try to reinvent the wheel. you're probably just thinking on the side and not really thinking on the problem itself. So just send a message on the channel. That's why there's lack. That's one of the main reasons of the Slack being there. Sometimes it's just a little tip or help here that you will open, like you see that you were doing something wrong. Sorry, I got lost on my rationale. But essentially, if you spend more than 3-4 hours in one exercise and you have no idea how to fix it, that's a good indication that you should ask for help.
Yeah.
That's
less. 3 or 4 hours is already enough. I mean, you normally have 10 to 20 hours to solve all the exercise, so 2 hours is already too much effort in a single exercise.
even on your day-to-day job, if you are stuck with something, most likely you should ask someone or get a new set of new pair of eyes to have a look on your code. There's normally some simple things that you're missing. Alan got a question here around make files. How you should do your make files, use this or that. But it's essentially because the class is not about make file itself. So we normally just show the basics, but then how much complexity you want to put on your files, it's up to you. It's more like how to use into that pattern to use for infrastructure as code and those things. But we're happy to discuss about those. Those are things that don't have right or wrong answers. It's always good to discuss. So send those questions on Slack, and sure, Kiku, Dennis, and I will have different opinions on those topics. And thanks for reviewing all of the exercise, man. You're doing more. You're reviewing more than us.
No, that's good.
That is
I'm enjoying.
That's literally helping a lot us to your reviews, and you are providing some great feedback for people. Thank you for that.
Yeah, I'm trying my best.
We learn a lot reviewing other people code that, isn't it?
Yeah, for sure. Maybe because sometimes I stop to. Sometimes I myself have some doubt. I'm not sure if what's wrong or right. So I do some research as well on my side and follow the other codes and see which one is the best. So it's good for myself as well.
Hello.
Hey Jay, how you going?
Oh, okay. I was wondering what happened. Okay. Good.
We can hear you.
How are you guys?
All good, Jay.
Oh, good.
Enjoying the wonderful lockdown?
Well, the most we can, right? And I need to buy or make some face masks myself.
Yes. I'm thinking of having a mask with some like images kind of thing. You can have funny stuff here. Smiley face, a mustache.
Take a picture and send us, please.
But if you're going into a bank, you have to remove the mask. That's what they're saying. So if you're, let's say, if you're going into a bank to get some job done, then you have to remove the mask because
They can identify you or something.
Yeah. Otherwise, you cover here, you have a sunnies, and then No one knows who are you.
Mm.
Was no more questions from the stand-ups, or if we miss anything, we'll use Slack to reply later. Thanks for the feedback for the class itself. Apparently everyone enjoyed the exercise and the content.
Yeah, good stuff.
Should we get started? We have everyone in the room. Think so.
Yeah, we have.
Cool. Let's get started. As always, there's a dump of information to share with you guys. With some sad news, we lost 2 of our people. Sharat, is it Shara?
Sharia.
Sharia, yep.
Yeah.
He had some health issues, some personal issues. He's leaving us, and Igor as well had some personal issues and won't be able to attend to the rest of the classes. They won't be able to commit their time, so they decided to just leave. That's unfortunate, but it happens. Today we will cover we'll introduce to you guys the project at the end of the class. The first project is going to be a group project. We'll divide you guys into a few groups, and then you have to work for the next few weeks. We won't have any exercise for the class itself today, I think. And so you guys can focus on that, but we will have more details later on. We have two special guests today. One is one of our former students it's listening to the class again. Just I thought he mentioned that as well, Matt. He said that he wanted to cover Terraform again because still need to practice that. And our first presenter today is Mateus. He's a solutions architect at AWS, and he will be covering the first part about ECS. I'll leave it to him to present himself. And then the second part will be Terraform with Dennis. I think we can jump straight into the content, right? We have quite a bit to cover today.
You want to share the exercise?
Yes.
Let me just share the screen here. Just so in regards to exercise, if you guys can see the screen, we're not reaching very greeny as we expected. So this week you guys won't have a lot of exercise, so it's going to be a good week to try to catch up before starting with the project. So it would be good to have something around at least 85–90% of those exercises done. With the 2 people leaving us, those numbers will get better next week because we are removing pretty much a lot of the people that are not doing a lot of the exercise or weren't able to do a lot. So those numbers will be up. But if you guys can see, there's still a few red spots in the chart. So yeah, let's just try to keep up with the exercise. And if you need any help for an exercise, just reach out to either of one of the 3 of us or even to a colleague. I'm sure anyone will be able to help. So let's see how it goes next week. Cool.
And a shout out to everyone that have completed all of them.
Yeah, well done. We have 1, 2, 3, 4, 5 that completed everything, which is good.
You would get a sticker as Kiko shared the picture on the channel. It's unfortunate that we can't see you guys. We might ship one for you after the end of the course.
Yep.
I'll leave to Mateus then. It's all yours, man.
All right. So can everyone hear me?
Yep.
Okay.
Yep. All good.
So I can see some well-known face here. So Fabu. Yeah. So guys, what I would do, I'll share my screen and I'll start a presentation. So just let me say, let me know when you guys can see my screen.
Yep. Yeah, I can see.
Okay. So I'll start with an introduction. So my name is Matthew, or call me Matthew, but some Brazilians will say Mateus, but you can call me as a Matthew. AWS Solutions Architect. I have around 15 years of experience. In Australia, I was a .NET developer. I started as a .NET developer and then I also worked for CMG Solutions together with Kyle. And of course, now I'm working as a solutions architect here at AWS. So the topics that I will be covering today, you can find in this page into the GitHub. So I will start with ECS, and then I'll jump to ECR, and then I'll show you some things about SDK. Oh, sorry, CDK. And then I'll put on a channel there if you guys could install the ECS CLI and the Edge desktop version of the Docker, so you guys can follow me in one of the deployments that we do into the account, so you'll be able to follow me and deploy a cluster. Okay, so before I start, I would like to know, is there anyone here that has already used ECS, ECR, Firegate? Is there anyone with experience except the DevOps Academy guys?
I've used ACS before.
Artin, I used ECS before.
Yep.
Okay, so what are the products or what do you deploy over there? Is like an application, is a batch, or you just was learning?
Oh, a bit of both. A small application at the place I work was running there. Did a bit of work on it.
Okay.
And then we stopped for a couple of years, and then we're getting back into it now. So it's good timing.
Yeah, that's great. Okay, so I will keep following here. So first, before, So what is the idea of ECS? As everyone knows, we have the Kubernetes option, so you can deploy your containers and do an orchestration. But of course, AWS also has its own orchestration tool for containers. And then ECS is like highly scalable. Has high performance and then supports Docker containers. So you can have your Docker, and then you can use ECS to deploy that, and then deploy your service into ECS. Of course, for the ECS, we have two types of deployments. One is you can use EC2, the EC2 instance, and ECS agent. So basically, ECS will manage to deploy your Docker into those instances, or you have another option that's called Firegate that I'll show you guys later. I'll have a quick 2-3 slides PowerPoint that I want to show you guys, just to make it easy to understand what I'm trying to talk. I'm not going to go through slides, but just for that one, because I think, can you guys see my screen, my PowerPoint?
Yes.
Okay, let me just find, where is that? It's not showing. So as you can see here, it's very simple to run one container. So you can have your EC2 machine, you can install Docker, or you even into your own machine, and then you can deploy your service. But when you're talking about many containers, it becomes so hard to deploy and manage. That's why we have ECS that can help you manage that. So I think that's why I brought this PowerPoint, because it kind of shows you, that's running, it's easier, but when you have multiple containers, it becomes complicated, and that's why we have ECS. Okay, let me get back here. So is it clear for everyone what the ECS does, or how this actually works? Is there anyone has any question about ECS? I'm going to go through the details of how to use and or the idea of using ECS, but is it clear about what ECS does? Is there anyone that has a question?
I do have a question.
Yeah.
So basically, the ECS is kind of an integration tool just to deploy the container in the machine itself.
It not just for the machine. It kind of so you guys had a course about Docker, correct? So you know how the Docker you create the Docker file, right?
Yes.
You have the image. So once you have that image, you can go into your Docker look in your machine, and you can run, and you have the service running, correct? So the ECS will do kind of the same, let's say in a high level overview. So it's going to do the same, but helps you orchestrate. I'm going to go through some of the use cases as we go down the course. But it helps you manage. So you can, for example, let's say you have a web service with two service running, and then if one of those just exit because you had an error into the application, so the ECS can go there and, okay, that one is dead, let's put another one because you had a problem with that service, and just put it back to two tasks.
So it's sort of the similar to the AWS, the load balancer thing for EC2, but that's for the container layer.
Let me see. Yeah, kind of the idea, but the load balancer would do a different way. So the load balancer will, let's say you get a request into the load balance, let's say aob.com.au, and then that AOB will get into a list of machines and will distribute the connections. So the ECS will just manage and keep the service running. You can even have like individual IPs per service, you know, like per container running,
Yeah.
and you can access them individually. But the EOB, it's kind of a, let's say in a high level, like a unique URL, and then when you hit that, it distributes among those other servers. Could be a EC2 or could be a ECS.
I would say that if you want to do a relationship, Guilherme, it's more like the ASG, the auto-scaling group, because the ECS should just do that. If you say, I want 2 instances of the container running, ECS will make sure that those 2 instances are running. So it just
Okay.
make sure that the service is running and the number of replicas of that services that you want to provide is running ECS. So it's more orchestration tool than the AOB itself.
Yeah, I think for this, so the ASG will be kind of what do you, if you want to compare it, you have a better view of what happens behind the scenes. Yes.
Okay. So yeah, I understood now. I was trying to remember the ASG name, but came after as load balance.
That's
Yeah.
okay. But if you see the EKS or the Kubernetes, it's kind of a similar idea, but the ECS is the managed service by AWS.
Okay.
Okay, but if you understand how the Kubernetes works, it's kind of the same idea. So, but it's ECS is developed by AWS.
Okay.
All right.
Thank you.
No, you're welcome. Yeah, guys, feel free to interrupt me, and we can, you know, I can answer the questions if I know. Is there any other question, or can I continue? Okay, I'll get the silences. Yes. So the main, let me just zoom, make it easier. I think it's probably better now.
Much better.
Much better. Yeah, sorry guys for this. So the ECS main use case, you even have more, but our point 3 here, we have microservice. So you can deploy your microservice and you can have multiple services and then connect to each other. I think that's the most well-known use case. We can also have batch jobs. I'll give you an example that I have a customer that's developing. So they're going to receive a lot of images and they want to process those images so they can use as a batch and they can have those services running. And then once the image comes, they process the image and get the output. So it's not accessible for an outside, but it's processing jobs. And it's one of the use case. And then another use case that's coming as a common now is the machine learning. So we have some customers using machine learning and then ECS, they create a Docker file for machine learning and then they can run on ECS. So these are the 3 main use cases I've seen here. And of course, the main one most people are using now, it's a microservice. So now let's think about the deployment types that we have. Let me see if I can zoom that image here. As I mentioned before, as you can see, there are 2 ways that we can deploy into ECS. The first one, we have the ECS here on top as a layer, and then we can use EC2 instance to start placing your Dockers. And then if you have, let's say, 3 instances here, and then ECS, we start placing your service, your container into those EC2 machines, and then once someone hits your service, the call goes to the EC2 machine and then returns. So you need to manage the EC2 instance. However, there's another way that we use now. It's called AWS Firegate. It's the same idea about serverless. So who here has used Lambda before? Yeah.
I start to use it, but just once. I upload some images and getting it back. And
okay, so How do you feel about this? You like the idea of not managing your service? You just put your code and execute, and then you don't need to worry about your Windows or your Linux if you're updating, or how do you feel about that?
I just believe that you'll be working every day and whenever question. That's fine.
It's a good word.
Well, that's the idea, and it actually works, to be honest. So because I was a customer, I use it as a customer too, and then I had great results out of Lambda. But here for ECS, now we have this Firegate. Instead of you managing your EC2, you put your task into this Firegate, and we manage the host for you. And then we deploy, and then we put your task to run. So these are the two types of deployments. And then if you want to use the ECS, you need to have this container agent. So if you want to use the EC2, you need to have this container agent. We have some pre-baked images that when you're deploying your ECS that comes with the agent. However, you can also install into your own EC2 machine and then also deploy to that one. But it's a little bit complicated because you have to follow a tutorial and then set up the agent to communicate with your ECS. So the recommended step if you want to use EC2 is just to go into the baked image to deploy your stuff. All right, so when you're talking about Firegate, I think it is also good to mention about Firegate Spot. So the same way we have EC2 Spot where we have some spare capacity and we sell in a cheaper price. We also have the Firegate Spot. What is the idea? So we have a lot of compute that we're not using at that time. And then as you know, using that, we can just, sell the spare capacity. And if you need that capacity during a specific period, we can claim it back. And then you have 2 minutes to shut down your application. So when you're talking about Firegate Spot, you can save up to 70% in cost when using Firegate Spot. But of course, your application needs to be able to handle the termination, because you may be in the middle of processing an image or receiving a request, and then you're going to have just 2 minutes to terminate. It's not recommended, for example, for database, because imagine you're having a database and you have to terminate, so it's not going to work really well. But for stateless applications, should work fine if well designed. So, and then, I have some tutorial here how to use, you can go later on into this YouTube video that shows step-by-step how to set up your ECS to use Firegate. And then as you can see here, when you use Firegate, you focus on your application instead of managing EC2s. It's completely serverless. So you just have your Docker, you deploy, and then goes live. And then that's why I've asked you guys to install the ECS CLI, because I'm going to deploy sample application that we can see that actually working. All right, so now let's talk about the concepts that we have for ECS. I have that in details here, but first I want to show you that image that is really easy to understand. For the ECS, we first start with the cluster. So cluster is where we're going to manage the resource. For example, if we have the EC2s, okay, so it's where it's going to be living in the cluster. So you're going to have like your ECS, and you have all your EC2s under this cluster. And then to run your, let's say we call it as a service. So to run your application, you have to create first your task definition. That's your actually Docker file. That's where you mentioned about your Docker file. You mentioned about how much CPU and memory you want to use. And then you attach that to a service that will keep that running. You can run a task without using the service. That's where we do a batch or just one-off execution about your task. But you can also attach this to a service. And then when you set, for example, I want to be running 2 times that the task definition. So you're going to have this 2 run at the same time. If someone, one of those dies, you can just, the service will relaunch that for you. And then of course you have your container definition that's part of your task. I will show you here. So if you have an ECS, this is one example. So I have a cluster, all right? And then that cluster here, I have my cluster called ECS with EC2. And then if you click here, that's of course I've created as a sample because it takes a little bit while to deploy. You can see that I have my service running here. And then also I have my ECS instance that's actually an EC2 machine. All right, and inside here I have this task running. So if you see that task is part of the service I showed before, and it's running inside of this instance. So ECS deploy that for me and manage that for me. If somehow this get an error and then throw an exception and dies, it's just going to relaunch that service. Oh, sorry, that task. So that's the high level. Is there any question about this? Is it clear? Do you guys want to get more information or?
Oh, oh, sorry.
Yeah.
The task definition as well as the container definition, both of them run inside the instance.
Yeah. So if you see here, hold on a second. I think you have a better image here. So if you see here, I have the task definition.
Yeah.
All right, and then once it's running, it goes to your Docker register and then download, or could be the ECR register that we're going to talk later on, and download the image to run here into the machine. Is it clear?
Yeah.
Is it what you're expecting?
Yeah.
Yeah. And then that image that'll be running into the EC2 or Firegate. So if you're running Firegate, that's also be running over there.
So it's likely a Docker Compose file, this task definition.
The task definition is kind of, if you see, I have a sample here. I think I do have a sample here.
It's kind of.
Yeah, kind of. I want to show it, but we have a new release that I'm going to be talking about. So basically, let's say this new release that's is due in a preview, you couldn't actually deploy straight away from the Compose, but now there's a new tool that helps you deploy straight from your Docker Compose. So I'll be talking about that later.
And the Compose can have multiple containers, right? The task is a single container image, right? It's not like a pod in Kubernetes. It's just a single container that is supposed to run.
Yeah, you can have multiple ones if you go. Let's create one here.
That's nice. I didn't know that.
Yeah, let's say that one here.
You have multiple containers on there.
Yeah, you can add multiple containers here.
It's like the pod on Kubernetes. Yes.
Yeah, if I'm not really good with Kubernetes, but I'm thinking he can go up to 10 containers if I'm not wrong. I'll have to double check, but if I'm not wrong, can go up to 10 containers here inside. A good use case about using multiple ones. For example, if you see we have app mesh and we have the X-ray. What some customers they are doing, they run the container and then they add the app mesh, that's another container, and the X-ray, that's another container. So when you see here, you can see multiple containers running. I think I even actually have into the accounts. Let me see if it's here. Task.
Hey, Mateus, just some tips from running this a few times. Stick to your GitHub, or otherwise you'll run out of time.
Okay, yeah. Sorry. So let me finish this with this. So if you see, that's a demo that I was testing, and then I have my actual application, and then I can have the Envoy and the X-ray. All right. Yeah, thank you for the tip. Let me get back here.
I've done that so many times.
Yeah, no, it's my first time doing a session like this, so get feedbacks later on would be good. So is it clear now about task, service, and cluster? So you guys have a good view about that, how it actually works, because it's important to understand that you have your cluster and then you create your task definition, and then you can even deploy that one, or you can do as a service and you can have multiple of that task running, like 10 tasks.
So one task is one or more containers.
Yes.
Okay.
But it's not actually running. So the task definition, nothing is running to task definition. So once you deploy that as a test, that's when it start running. So your test definition is kind of a template.
So if your service has multiple task definitions that are dependable on each other,
yeah,
when you have a service, what I'm trying to say is when you have a service, you should have only related task definitions in that one service, or is it?
So can you rephrase that?
So let's say you have a bunch of task definitions. They are related, like the database and application and something like that. Monitoring service. So three task definitions, but they belong to a single service.
Yes.
So, but you should try to keep these task related task definitions only in one service. You don't have like random task definitions as a collection in a task.
No. Just those ones related to your application. As I've mentioned, the other one that I have as a sample, those three tasks are related. So I have the envoy running together with my task to collect the data from my application.
Gotcha. Yeah. Thanks.
Okay. Yeah, you're welcome. So it's really important, and I think that image here shows, you know, how it actually works and how they connect to each other, and I think that's really good. So I already mentioned, but here we have an ECS task, and it's actually a JSON. So you know, it's kind of a simple to understand if you played already with JSON, and then you can see he's running Firegate, and you can specify memory and CPU, but you can use as a JSON, or if you're not 100% sure how to do it, if you go here to task definition, you can create a new task, and then let's say, and then that memory, and then you see the JSON option here. So that's when it generates for you if you're not 100% sure. So I would recommend you go into that tool to generate a JSON for you. Okay. Yeah, so let me get back to my notes here just to see if I'm on track. Fargate. Yeah, so I have the service, so scrolling down. As I mentioned, you can do it through the interface. And then we have the cluster. That's when you put your tasks to run your service, so you can have multiple service per cluster. Okay, so you can have multiple service running there. And here's the actual service. All right, so as you can see in the image, you have a service, and I have the task definition and the service description. So that will deploy and then manage and orchestrate your containers for you. Okay, so that's about ECS. That's the general idea about ECS. It's not really complicated, being honest. It's like a simple idea. That's all about ECS. Do you guys have any question, or can I just jump and then start with the ECS CLI?
Only one quick question. So you have two models. You have the shared EC2 instance and the this Fargate's only one instance. So when makes sense to each every mode? On the first slides, you can choose between host in EC2 instance or run like the container as a standalone thing.
So if I understood that properly, let me get back to the PowerPoint. You mean that slide here?
Yes, no. No, the first slide, you have the containers running inside EC2 instance, I think is this one. And on the, was other, you have like a fleet of EC2 instance.
Yes.
And
is there one
yes,
here on
here.
It's that one here?
Yes, yes, when one makes sense to use each one of that.
Okay, good question. So basically the way that I recommend is, for example, Firegate, it's a little bit more expensive than EC2. All right. However, you don't have to manage the EC2. You don't need someone to manage that for you. Because when you have the EC2, it's actually, even when you're creating, if you go all the steps through the website, you set up your SSH key. So it's kind of your machine running into your account, and you have to manage that. But when you have the Firegate, you don't need to manage that. It's like play, you know, you just deploy and that's it. You don't have to worry about how you update that, or if you know if you're doing patch update or things like that. We manage the Firegate.
Okay, I got it.
And then my recommendation would be, like, if you're a small team, you don't have time to manage, you know, you just want to quickly deploy and focus on your application, why not go through Firegate? And even if you can have Firegate Spot, you just save 70% in price.
Oh, good. Thanks.
Essentially, Fargate, you pay for what you use. So every time
that's a good point.
Stands up a task, you pay for that. If it, for example, if it's a job that you need to run, might be much better to do on Fargate. If it's an application that is 24/7 and you have the knowledge to do the EC2 and you have people skilled to support that, might be cheaper for you. That might be a cost problem, cost decision. Yeah, both options are widely used today.
Yeah.
Thank you.
And then some of my customers, they just realized that a lot of times it's better to use Firegate just because they don't want to manage the EC2. At the beginning, they say, okay, I want to manage the EC2, it's cheaper, and then they realize they need someone to manage, and then we have to pay someone to, you know, keep that running. And then, okay, why not put it into Firegate and do, you know, that for us?
Hey, may I ask you another question?
Yeah, go ahead.
So just to exemplify and understand better, imagine in a real world, I would have like a container for my front end, a container for my backend application, and a container for the database. So I have 3 containers. I go there, create a cluster, create a task definition. I would create like 3 task definition, one for each or one for those 3, and how the service getting to play like together with those 3 containers, for instance.
Yeah, first answer your question, yes, you need one task definition per service. And then you're going to create it one, because they're going to use different memory, right? So your front end may use a different memory from your back end. So you must, in my opinion, you must separate them to make it easier to access. And then you can either, we have another service called, it's not an app mesh, it's the, hold on, I just always forget the name, is the, you can either use like a load balancer, or you can use kind of a directory. Yeah, it's called Cloud Map. Some of the customers, I'm not going to go through this because I may not have enough time, and then I will just follow Kyle's recommendation. But you can connect those servers and they can route, because they're going to have IP. So you know, you can have a load balancer, and then you connect to this load balancer and then access your service in the back end.
So the service layer of the ECS would be this load balancer thing.
Yeah, you kind of have like the service A, and then you have a load balancer, or you can even be the cloud map, and then connecting to your backend, and so connecting to your database. Well, I can take that offline, and I'm on Slack channel too, and I can even give you some diagrams that shows how you actually connect in.
No, I don't want to connect. I just want to understand the service bit of the ECS.
No, yeah, it's a good question.
Yeah.
Can I try to, I like to make a comparison with EC2. It's not the same, but essentially, the EC2 will be your task definition. It's just that the task definition could be more than one EC2. Your service is your auto-scaling group. The service will make sure how many task definitions are running in one point in time and those kind of things. And we'll also provide you volume and other things that we'll see later. But essentially the service is the ASG and the task definitions is the EC2. And then you also need your load balancer to connect to your service, to connect to your EC2. Does that help a little bit?
Yeah, helps. Thanks.
Yeah, and I would recommend you going through this cloud map. Is also another tool that you can use as an internal kind of a load balancer. Okay, but just you can check that later. It's good to learn. All right, so I'll go ahead with the ECS CLI. So does everyone here install the CLI as of us on a channel? Because I can wait, but otherwise I'm just going to go ahead and execute the commands. And also what I want to, so I guess everyone here has used the AWS CLI, am I correct?
Yes.
Okay. Yeah, so before I start running those commands and explaining one by one, I want to mention about two things that I'm using here. The first is, let me find one here.
They're all masters in AWS CLI.
The first, that's good. The first thing that it may not have used before is the filters. So if you see here for that command, I'm filtering by VPC ID, and then I'm giving a number, and then that he will just return for that VPC. So you can apply a filter to your commands. Another one is the query. So if you do query here, so when you receive your JSON, you can tell, okay, I just want to get the security groups and the group ID. So within the JSON, and that's the only information that will be returned. All right, and then the last thing is the output. So I'm outputting that as a text. Okay, so what I've done here, you have this lab into the AWS documentation, but I've changed it a little bit to use variables. So if you see here, instead of running that one, copy and paste the number and then put into the next command, I'm using this VPC ID. And then once I execute this command, I put this into this VPC ID variable. And then if I run the next command, that's to get the secure group ID, I have the VPC ID here. So it's kind of the way that you do into your pipeline to deploy. And then it's different from the actual documentation, because the documentation just asks you to get the numbers and replace. But here you can just run the commands, copy and paste, and will work. All right, so what I would do, I'm gonna skip this 1 and 2 because I already have the IAM row. But if you're doing that with me, just quickly execute those 2 commands, and it's going to create your execution task row to run your container. All right. Okay, moving to the next command, what I'm going to do, because at the end of this step by step, I'm just worrying about time. So Kyle, do I have time to run all those commands, or do you want me to skip and let them do it?
You probably can run, but just don't wait. Just show.
Okay. So what I'm, because now it's, yeah. So what I'm doing here, using the ECS CLI, I'm start building my cluster. And then if you see, I've executed that one. I've set up my cluster locally on my CLI. But if I go to my ECS, I don't have this tutorial cluster yet. So once I do this ECS CLI app, that's when we start creating CloudFormation. You guys all know about CloudFormation?
No.
No? All right, so you guys going to be learning about Terraform. CloudFormation is kind of what Terraform does. So you can do your infrastructure as a code. So you have JSON or YAML file with the information about your stack. And then once you execute here using CloudFormation, AWS will deploy your infrastructure. So what it's actually doing here, it's building, if you see the resource, is creating your VPC, internet gateway, and everything related to your cluster. So if you see here, it's still in progress. So it's running. Let me get back to the next command. And then, as I said, you can go to your, yeah, done. So if you see now, CloudFormation executed that for me, and then created my my stack. So I have a IP, VPC, and everything ready to start deploying. So the next one, I'll grab a few information like the VPC ID, the security group ID as a variable, because I'm gonna create a security group allowing that allowing access from outside. So everyone in the internet will be able to access my container. And then in order to execute, to change the security group, I need to pass the information about the security group ID. So I can go here and get the security group ID, or I can programmatically get that information using the CLI. But as Kai said, you guys already know about the commands. I'm not gonna explain in details.
They love CLI.
They love CLI. And then as you can see here, I can do an echo. I can do things like this, echo. Oops. And I have the security group information. So once I click, I want to say execute that one, I'm going to allow, oops, sorry, everyone from the internet to access that security group on a port 80. Okay, so now that the specific security group created for this lab can now be accessed from the internet. So now what I'm going to do, I'm going to get the subnet ID that was deployed from the CloudFormation. And then, and also I'm using this AWS CloudFormation describe stack. So once you create here your CloudFormation, if you use this CloudFormation describe stack, you can get information that of the resources that you deployed. So what I'm actually taking here is taking the subnet 1 and 2. The next one, I'm gonna change this ECS perms.yaml because that one's gonna be used to deploy your task. Oops, sorry. I need to be into the ECS folder. No, I'm the wrong one. Sorry guys, let me just go back to the right folder. Yeah, so what I'm actually doing is just changing, if you see this ECS. So I've just using this command, I've just replaced this subnet details and the security groups for my task definition. And this YAML file is going to be used to deploy our application. So now the last one is this ECS CLI Compose. Oops. Oh. Okay. Invalid group. So guys, that's a task for you. So yeah, as you guys are seeing the lab, if you find the problem, let me know and you can get a sticker from Kyle.
It's the security group that is wrong.
Is it? I've used the command, so probably.
Can you open your CloudFormation?
Let me get, oops, CloudFormation, resource.
Where is your security group?
Well, it's supposed to be coming together. For sure, I've done 2 times to ensure that it worked. Security groups.
The security group that you created with your commands, it starts with 00F8, and the one that you have reference is 08.
Probably the command was running into the different one. Hold on.
I think the file that you had there, the YAML file, didn't have the.
Ah, yeah, that's true. Because I've used for testing before, I forgot to replace. Hold on a second.
So you probably have done this testing before the class, and then you
forgot to replace. You're completely right.
You got yourself a sticker, Kyle.
He's owning a sticker list for everybody, even himself.
And those things just happen when you are doing a demo live.
Always, man.
Demo of demos, yeah.
Let's run this again because now I have brand new file. I'm just doing cat. Yeah. So if you see here now, as you can see, you have this subnet IDs. They're going to be replaced by this.
It's wrong.
Sure.
Oh, no, sorry, I didn't see the space there. Sorry. Yeah.
Yeah, no, it's just replace it. Yeah, it's right. Should work now. Thanks, Kyle. Yeah, that's about the security group. Don't worry about this just because I already had that security group. Have that, and then Stu creating.
It's important to mention that with ECS, you don't pay for those tasks, services, and those things. You just pay for the underlying resource that is running for you, like the EC2 instance. Or if you're using the Fargate one, then you of course pay for the Fargate service.
Yeah, and the Fargate you pay per Fargate that you launch.
Is that included on the free tier, the Fargate?
That's a good question. Probably, I'm not sure. I have to check.
Yeah,
so sorry.
No, go for it. Sorry.
Yeah, so if you guys see here, the command saying the creator is an ECS service, and is actually here. So that was deployed using the ECS CLI. Okay, so I'm going to go ahead just because I'm conscious about time. The next command here, as I said, I could see using the console, but if you run these commands, that's the PS1, and you can see that's running. And here you can see the public IP if you want to access the box directly, or the service that you're running directly. And if you have multiple ones, you're going to have multiple IPs here. And that's when you have the load balance in front, that you can have a single IP that spreads against the other service that you're running. You can also see the logs, and you can also scale. If you see here, I have only one running, but I can scale. I have only one task running, but I can scale to 2, 3, 10, and then that will start scaling the tasks. Okay, you can have multiple. And then if you open the URL or the IP, as I can have the IP here, I should be able to access the website now. So now I'm accessing the application that I've deployed. Oh, sorry about my image in the background. It's getting black. Okay. So is there any question about this? No? And then if you follow this, don't forget to remove the service, otherwise you'll be paying for them. Okay, so you can just easily run the commands to destroy what you've deployed, please. There's another one that I won't get much in details, but it's a Copilot CLI that's on the preview, and then helps you deploy your application. So as you can see, this GitHub here, once you open this and clone, you have the Docker file, and then you can say, you know, I want a type of load balancer web service. And then what it does is build your image, upload, and just do everything for you in a high level. Okay, so I recommend you guys checking this out, because you can put into your pipeline and deploy production workloads using that command much easier and simpler. Okay, so it's on the preview. It's on the preview. Now, so I'll move to the next topic. So it's ECR. As you know, we have the ECS. That's where you host your application, and also we have the ECR. So you have your container registered. The same we have the Docker Hub. Okay, you can have the same into AWS. That's called ECR, and then you can easily integrate with your ECS that you can get the images from there. And then it's pretty simple idea, and you can also manage the access of that repository by policy. So if you see here, you can describe the repository. You can apply IAM policy for this. Another good thing about the ECR, you can do image scanning, which means for vulnerabilities. So once you upload your image to the ECR, ECR will scan your image for vulnerability, trying to find vulnerabilities. So, and it's really easy to enable. So you just do this on a command line, like scan on push through, and then once you upload your image, the ECR will start scanning and give you reports with all the details. And then it's pretty simple to use. You can see those steps here. But what I have a lab here that I can do. It's very quick. So if you can even follow that later. So what I can do, I can create the repository using a command line. Simple as that. The repository is already created. So if you go on the same console of the ECS, you can just go click on repositories. And you can see this my repo that I've just created. Of course, it's empty because I don't have any image. But I've created a Docker file just for testing, and then I can build here. I think it's, yeah, it's because I've tested before, so it's very quick. And then I can get the ECR URL that we're going to be using to push the image. The same idea, using the variable. And then what I'm going to do, I'm going to put a tag to my to the image that I built locally using the ECR URL. So if you do Docker image, you can see that now I have this here. And then I will authenticate my Docker client because I'm not going to, oops, sorry. I'm going to authenticate my Docker client. So my Docker client can send the image to ECR. So now I'm logged that one. And then once I do Docker push, oh, sorry guys, I'm just trying to do the same as the CLI. So once I do this, we'll just send the image to ECR quickly. And I'll show the vulnerability reports. And then when you guys do yourselves, you can put some challenge here. One is trying to get the AWS CLI to download the vulnerabilities. And how can you delete your repository via CLI? It's kind of easy, 2 commands. Sorry for the delay, it's finishing. So if I get back here. Three more seconds. Yeah, done. So now I have my image here that I can use with ECS. And then I can point the tasks, task definition to this image. Okay, so all running into AWS. And then as you can see here, it's scanning my image to get the vulnerabilities. I may not, yeah, it was quick enough. So if you see here, at least all the vulnerabilities about this image, I think it's quite useful. So ECR that's it. It's very simple as it is. Any question about ECR?
Can the ACR like update your images when your base images update automatically or something like that?
No, I have to push your image as far as I know.
Oh, good. What are that policies you have in the screen? The life cycle. Oh, you should on your ECR tab, Amazon ECR, the second tab.
The second tab.
Yeah. Yes, you have life cycle policy. How?
Oh, it's just to delete your image, so you can put a life cycle because you start creating a lot and then you pay for the storage, so it's just kind of a cleanup.
Oh, cool. Thanks. It was very clear.
You're welcome. Yeah, and then if you're not 100% sure of how to use the commands, you have this here, the push commands, and then tells you how to just copy and paste and run. Okay, so I think I have 4 minutes left.
You have a little bit more because you start at around 35.
Okay, yeah, but be honest, it's just the next one is about CDK. And I think it's I have the Compose. So CDK is very quick. You guys are going to learn about Terraform today. And then CDK is the way that you can deploy into AWS using like TypeScript, Python. And then as you can see here in a sample using, I think it's Java. So it's Python. Yeah, it's Python. And then, you can do the same thing. So you create your Fargate service, and then, you deploy, you get the outputs. So, and at the end, what it does, it generates for you a cloud formation and then deploy on your behalf. But instead of creating a YAML file or JSON, you can programmatically create those resources. Okay, and you have a lot of information into our documentation that shows you how to create the instance, how to deploy VPCs, and it's pretty simple because as you can see here, you're creating a VPC. You don't need to provide a lot of information, so you get some defaults here and just deploy the VPC for you.
Just out of curiosity, HashiCorp, the company that created Terraform, they partner up with AWS, and they also released the CDK for Terraform. So it's still in beta, but you can download and start using from today. You can still use TypeScript to generate your code, and then what it does, it generates your Terraform scripts for you, so you can just run the Terraform.
I was about to mention that. Thank you for this. Yeah, that's really good. But of course, it's still under preview. It's not ready for production, I guess. But the same idea. Use the same idea. You can use the language CDK language to deploy that. All right. So that's about CDK in high level. And then I think that's the last one. And the last one that I want to talk is about Docker Compose and ECS. As we had a question at the beginning, so you have your Docker Compose file where you have all your servers. But before this I think it's still in the preview, you couldn't actually deploy directly from the Docker Compose because you have a different names and everything, so it doesn't have the ECS parameters. But now with this Docker Compose option, that's why I've asked you guys to install the Docker Desktop Edge. That's still on the preview. You can set up, you create the ECS setup using the Docker commands. You get the ECS as a context, and then you have this Docker Compose into that lab. And then once you do Docker Compose up, again, it started CloudFormation for you, but it deploys, see, Cloud Map, log group, and deploys everything for you from your Docker Compose file. So as I don't have much time, probably I'm not going to deploy this because it's going to take a while, but that's the output of the ECS Compose once you execute this Compose app. So that's all from me. I hope it was useful. If you guys have any question, please go ahead and do so.
I have one question regarding the Fargate. If I'm using a Fargate, using Fargate to deploy something, let's say something happened to my application and I want to really dig into the logs and to understand where the problem is. How much flexibility I have in that case if I'm using Fargate, because I don't know where it gets deployed.
Yeah, I had a colleague that was supposed to join here today, but he actually didn't. Jason, he has a lot of details about this. But what I can tell you is the ECS cluster. You can, where's that tutorial? So if you go, let's see this task here. You can output logs from your task that's running. That's an option. But there are other tools that I can probably even paste that later on, that you can get more insights out of your service. But I'm not really familiar with all the options. But that's one of the options that you can get a log out of your application.
Essentially, you can configure the CloudWatch driver on your task definition, and then any logs that your container is generating will be on CloudWatch that you can check later. We'll cover CloudWatch on the next class. We'll probably try to do some troubleshooting on containers. That's for sure.
So as long as I can get all the logs out somehow, then I can push it to somewhere, Splunk or whatever. Yeah. Okay.
Yeah, from CloudWatch, you'll be able to push to Splunk. There's also a few other ways that I've seen around with sidecars. It's Kubernetes, sorry. If you have a second container on your task definition that is running an application forwarder, for example, a head forward from Splunk, and then from there you output, you send all the standard output from the other image to your service, to Splunk or any other.
Yeah, things like FluentD. You can use FluentD just to forward everything to Splunk if you want. So you have plenty of options.
Yeah, and if you see here, that's what I. Oops. I'm not sure if I'm gonna have that one here because I don't have any. But yeah, the logs will come to your CloudWatch logs that you're gonna learn later on.
Just because it was mentioned in the beginning, the EKS and the ECS, they do the same thing, container orchestration. They're used for the same purpose.
They're used for the same purpose, but the ECS, it's kind of managed by us. And then the EKS, we also manage the EKS, but ECS is kind of the high level service. So it's highly integrated with AWS servers like VPCs and things like that.
Thank you.
It's essential. Both are the same orchestration tools. Yeah, that's right. That's a right assumption. EKS is the Kubernetes offering. It's all managed as well. There is full managed options on AWS as well. And ECS, it's their own tool for managing orchestration, for orchestrating containers on the cloud.
Yeah, and the ECS you'll be running on AWS, but the Kubernetes, it's the kind of open source, so it's not related to AWS.
Thank you.
And then some of the customers, they prefer go EKS as they want to have a control of this. They don't want to run on ECS, but some of our customers, they just they prefer us to manage everything and they just deploy using ECS.
My personal opinion, I'm sure the other people will have different opinion, is if you have the requirement to have your solution multi-cloud possible, like if you are going to run your application in different cloud providers, you should be looking into something like Kubernetes to run, because it's a more open source environment and technology. So like Google will have the same offering, Azure will have the same offering. So essentially you can reuse most of your code moving around cloud providers. ECS, it's a thing for AWS. Whatever you develop for ECS, you probably won't have any use outside of AWS. But if you don't have that requirement of being able to go multi-cloud or to move cloud providers, I would pick ECS any time of the day. Like it's so much simpler to use ECS than EKS. And we'll be focusing the next classes and the group project on ECS as well. We won't be covering EKS on the DevOps Academy. Kubernetes in general.
Yeah, we would need a academy just for Kubernetes, pretty much. Yeah, it's way too complex for solving most of the simple problems and problems that we have. So yeah.
You guys have any other questions for Mateus? I know that he needs to leave soon as well.
Hello. What do you use to build and publish containers to Fargate? Can you do this automatically? Or not like a release pipeline or something like that?
What do you mean? Because if you see the way they've done here is kind of automated idea. So that's running on that one that we have here is running on Fargate.
Yeah, okay. This is the compute, right? But you need to upload a container, like a Docker container or something. Can you automate this? So once I finish coding my container, can I just commit to like push to GitHub or something, and it will just do everything automatically for me and deploy the image?
Well, if you commit that to GitHub, you need to trigger pipeline to start that process. So as you go up here, so that's the process about, you know, deploying. One of the processes, you can use the other command line, as I said, Copilot, but that's one of the processes you can do to deploy your image. And then you can have your pipeline to build and then deploy that. So you can go ECR, or you can go Docker Hub, and then following your commands to update your Docker, so your task definition. But of course, if you have your task definition using the latest one, you just force that to refresh, and then you're going to use the latest one.
Okay.
Quick question. If I deploy like a web application, where the SSL certificate goes?
The SSL certificate?
Yeah.
Well, depends. Are you landing into like a load balancer, or are you going, where's ending the SSL certification or the
Yes,
SSL?
this is the question. Maybe on the load balancer, or you have
Yeah, the load,
like ingress controller on the Fargate.
yes. Well, majority of my customers, they do end the SSL into the load balance, and then the load balancer do this the same for the rest of the application.
Oh, good.
Because that you won't be actually, you have this ECS, but you won't be using like one task and then accessing the task directly. You may have a load balancer in front of that, and then you have your certificate. So your users go over your this fixed endpoint, and then you can replace all your tasks in the back.
Oh, good. Is on the load balancer, that one used on the previous exercise, we have like a place to install like a certificate there.
Yes.
It's like a reversed proxy. It acts like.
Yeah.
Yeah. Oh, good. Thanks.
Cool. Any more questions? Just a final reminder. I just checked Fargate, it's not included on the free tier, so just conscious everyone money. You can still run the ECS normal one with EC2 with a micro instance, and then you won't be charged for that for the labs. But I would fire up a few Fargates just to have a play with it. It won't cost much. It's
yeah. I was going to mention that, Kyle. I just saw the price here. The price is basically per vCPU you have per hour,
memory,
and gigs you're using per hour. It is memory, right? Memory resources. And using Fargate Spot is about 1.5 cents per hour, but the minimum you may have is 1/4 of vCPU. So 1/4 of this price for the vCPU. So it's very cheap. That's the point. So for doing an exercise and experiment with it, I think it's worth it.
I would recommend you guys playing with Fargate Spot. And then if you see this tutorial here, it's an actual AWS one. Yeah, so when you had a time, just go through this YouTube video here that shows you how to select a Fargate Spot, how to split your tasks, because you may want to have like 2 tasks running into normal Fargate and then the rest running in Fargate Spot. Because as I said, AWS may claim the resource, and then you have 2 minutes to complete your task. So you don't want to have full of your tasks running into Fargate Spot, because if you decide to queue everything, you're just gonna lose your application so quickly. And then you can have 2 tasks run on demand, and then you can have the spot instance, so the Fargate Spot for the other tasks. So I recommend you going through this YouTube video that shows step by step how to set up that environment.
So one more question, like in the Fargate, do you also have something like, okay, my desired state or that kind of stuff? Like I need this many replicas of the task definitions?
The task, yeah, you launched your task. That's the task definition. If you see here into documents, that's when you actually.
Right. So when we say that, let's say my desired amount is 10, but current workload is, let's say, fulfilling only 2. So will I be charged for 10 in that sense, or will I be charged for only 2?
As far as I know, I haven't.
How does that work?
As far as I know, you'll only be charged for the resource that you use. So it's kind of a pay as you go. If you just have two running 2 instances of the Fargate, you're gonna be charged just for the 2.
Well, only okay.
Yeah. And then once you fire up the other ones, and of course, it's also good to mention about the auto scaling. So you can set up the auto scaling policy to go up and down based on the usage. So if you're getting a lot of requests, and then start scaling and putting more and more Fargate to absorb the requests.
Oh.
So yeah, you have the auto scaling for the tasks too.
I thought Fargate handles the scaling, scale up, scale down. Maybe I need to look into this first.
Yeah, Fargate. Imagine, let's just simplify, right? Imagine the Fargate is an institute. It's just the instance of your task. So you have one task running. You have the Docker file run, your Docker image running to this Fargate. All right. If that's only one compute running, so when you do this scale 2, what AWS creates in the backend is just get another Fargate. So you have 2 kind of let's say 2, just make it easy to understand, 2 EC2, so 2 physical hosts. So when you do 2 here, you get another Fargate, another host. It's not a host because it's the Fargate, but just to make you understand. So you have 2 instances of that task.
Got it. Thank you. So yeah, my understanding before was Fargate is like high level, very high level. What you're saying is Fargate is just one thing, and you can replicate the Fargates.
Yeah.
Right? Okay.
And then before I finish, if you see here the task definition, I think it's going to make it easier for you to understand. Once I launch this Fargate, it's only going to have 512 megabytes, and then the CPU units, I think it's 0.25. So that's the maximum I can use for this task. So that's the limit of my Fargate. So if I create a new one, make it easier here. If I create a new one.
So it's sort of a pod-ish thing.
Yeah, let's call it like that. So if you see, that's I think it was Kiko. Now Dennis that were mentioning about the price. So you can have 0.25 gigabyte and 0.25 vCPU. That's how you get charged. And that's the limit of your Fargate. That's it. So let's say your application is using too much of CPU, that's within that box. That's all. And then when you scale, you create another box with 0.5 gigabyte memory RAM, and then 0.25.
Thank you.
Does it answer your question?
Yeah. That's make it clear. Yeah. Thank you.
You're welcome.
Well, I think we'll have to wrap up here. I still have lots of content to go through and the project at the end of the class.
Yeah, sorry for taking too long.
Thank you so much for your time, for being this evening with us. It was much appreciated. It was really good content. Sorry that we keep jumping into the talk as well. It's just that we try to have this as a conversation, not as a class itself.
No, it was a great experience. Thank you for inviting me, and then of course it was my first time doing that online in that style. But I think it's great of interacting and then answering questions, because it's not just you guys learning. I'm also learning from this, because AWS they release new service quickly, and then it's hard to keep on top. So that way we can also keep learning too.
Yeah, I'm sure people will have some questions for you on Slack later on.
Yeah, feel free to ping me over there.
Thank you so much, man.
You're welcome. I'll stop sharing my screen.
Should we jump into Dennis' part? Straight into it?
Yeah, let's do it.
5 minutes break.
Well, what do you think, people? 5 minutes? 5 minutes?
Just time to go to the toilet.
Okay. 3 minutes then.
3 minutes, yeah. Good conversation on the CDK going on the chat.
Yeah, nice. Thanks, Matt. He cannot speak.
I think I like the idea. I think it has potentials, but it's too new. It's too early days. It needs more adoption.
Yeah. And well, I didn't know about this option of using it with Terraform. Was it built as a Python library package by HashiCorp, Kiko? Is it HashiCorp who is maintaining this?
Yeah, I think it was a partnership between HashiCorp and AWS, I guess. So
They did with Azure as well. So they actually released for Azure first, and then now AWS released one as well.
I just think that it's just a wrap up of something that already works pretty well. So it's just a different layer. So I don't think there is lots and lots of value. There are a few, but yeah, I think it's just get things more complex, to be honest.
Yeah.
I agree that HCL is not the best thing to learn. It's very limited sometimes, but again, yeah. For developers are good. For people that don't really understand infrastructure as code, could be a shortcut to learn about that area. I don't know. Yeah, my opinion is that it's still early days to move towards this. Need to wait to get more adoption, more widely adoption.
Oh, Tim, I liked your outfit. You removed it.
I had it on all day at work today, so lots of comments on it. Thanks.
Daniel is asking me a question here. Gonna try to, so you guys can jump as well. He wants some reference on the Azure part. So he's saying that he did a commit to the Azure DevOps, which I think in AWS would be the code commit, code pipeline, something like that.
Azure DevOps like a control, right?
It's essentially your source repository where you do your change on your code. We'll fire up a pipeline, either code pipeline or anything else, which is your CI/CD tool. That will build your image, will push to ECR, which is your local registry, not public, not using Docker Hub. Or you could use Docker Hub. And then your next step of your pipeline would be to update the service, so the task definition. On the task definition, you have an option that is the image that you are using. So you're going to change that image to the new tag that you just built and push to ECR. And then you just need to update your ECS service to use the new task definition.
They will have the experience that in the project, right? That's part of the project. They'll commit a new image, and that image will need to be deployed into ECS as a pipeline. So that's exactly how the project will work. So they're gonna have an example of that.
Does that answer, Daniel?
Kind of. So Fargate is like the compute and memory, and you pay by the hour. You pay by the time.
Yeah, and you will also get 20 gig of ephemeral storage.
Okay, so it comes with storage.
Ephemeral, yeah.
So where do you host the image? So when you push the image, so where does it go? Like a Docker image?
ECR.
No.
No, ECR, and the ECR will host the image like Docker Hub would host an image in Docker Hub.
Registry, okay.
The ECR, the ECS, you just pull that image and run the container as either Kubernetes nodes or ECS and EC2 or your local machine. So the Fargate is a specific way of deploying or running containers.
And where do you host like source control and the pipelines? GitHub?
Can be GitHub, it can be code commit and code pipeline from AWS, it can be GitLab. Okay. You just choose your tool.
Yeah, you don't need to use all the services from the cloud provider. You could use a mix of it. So just having everything on
use
GitHub,
DevOps. You can use Azure DevOps if you want as well. You can use Azure DevOps to deploy to ECR, to ECR the image and to Fargate.
What's the solution in Azure for image repository, Daniel?
Okay, the registry.
Yeah, so it's always easier to look at things, look at tools in categories, and that's exactly it. So ECR, container registry in Azure, Artifactory, Nexus, Docker Hub, they are all image repositories. They are registries for
exactly
containers.
Because I don't have experience with AWS, right? So I was trying to
yeah, to compare and like match your knowledge. Yeah. That's the easiest way, I think. Okay, so should we start?
Yeah.
Yep.
Yeah. Okay. Yeah. So now, guys, we're going to talk about infra as code. And as an example of this concept, we are going to look at one tool called Terraform from HashiCorp. So let's get started with what's infra as code. So the main purpose of infra as code is for provisioning infra, basically. So the idea is provisioning infra, but not the way we used to do in the old days. So probably some of you have done installations manually following some vendor documentation. Then you needed to run some scripts and you set up like a cluster of servers. You had golden images to avoid problems, but there was always a drift in the configuration, a difference between the ideal and the actual configuration. And basically, it's hard to maintain the state of infra. So the concept of infra as code comes as an approach borrowed from software engineering, where we have business logic as code, but this time for provisioning infra. So every server that you create, every network that you define, subnets, firewalls, they just become code. And when they do, you open a new set of capabilities, like for example, unit testing your infra. Of course, it's not like a business software. Infra is mainly integration, and when we do unit tests, for example, for software, we abstract the dependencies to independence inversion and other techniques. As here, everything is infra, then you need to do integration tests for that. But there is a bunch of tooling for helping you with that. And besides it, there are other gains, like now you can use a version control system like GitHub, Git as a whole. You can have peer reviews in your infra as code too, right? And besides that, after writing your code, testing your infra, pushing to Git, basically you ingest it in a pipeline, you build it basically validating syntax and other things, and you deploy it automatically. So all the steps you've done for the last class, I believe, doing manually with the AWS CLI, you could describe the whole infra just as infra as code using any of these tools. We are going to see Terraform, but I'd like to mention what we were discussing and Matthew presented. CDK is another option under the same category. CDK, CloudFormation is specific for from AWS. You have Terraform, and well, there are flavors and other stuff you can use for provisioning, Chef, and so it goes, the list. They're all under the same umbrella. They behave differently. So depending on your scenario, you'll need to adapt a little bit. We're going to see 4 different ways that these tools might behave. But in the end, the result and the business gain is the same. We want to have these code reviews. We want these code versions. We want to deploy faster and make sure we are always deploying the same thing that is the thing that was approved. And it links to techniques to avoid drift in your production environment. So, and even disaster recovery. Let's suppose you wrote some infra code for provisioning in your on-premises data center, because that's possible as well. So the idea of infra code is not directly related to cloud, but it's commonly used for cloud. But let's suppose you lose your data center, for example, and if they were applications running for 5 years or 2 years or 1 year, you don't have any idea of what was running there. And provisioning this infra again might be a pain because some key people might not be in the company anymore. And well, you can imagine. But if this infra is constantly being reviewed and deployed and redeployed, your chance for having these differences in the environment are lower. And you can basically redeploy your entire environment, infra and other resources, just running a pipeline, basically. So these are the key 3 benefits. So cost and speed. Well, speed is related to cost. Fast to provision, and it reduces risk as everything is reviewed and versioned in a source control system. And about the different methods and models we have, basically, infra codes can come into flavors, either imperative or declarative. A declarative model is when you define the state you desire in your system. For example, I want to spin up. I expect 2 EC2s running CentOS 7 with 4 gig RAM and 2 vCPUs. So we specify that. And when you run this infra code, you deploy it, it will check the difference between what we have in the environment and what you defined as the desired state, and will apply actions to compensate this difference. The imperative model is basically you describing step by step what needs to be done to achieve a specific infra state. So as an example here, you could describe the steps needed to create an S3 bucket, to create an EC2 instance, like in a script, for example. It's going to be code, yeah. So your infra is defined as code. You can version it, that's all right. But then I think it's harder to maintain because you need to control what about the differences in this environment, right? The actual environments and what you want to deploy. Who is going to manage these scripts? What's the pattern? So depending if you're adopting a tool or not, if you're just writing bash scripts, it can be complex to maintain mainly. About methods, there are two, basically push or pull. The pull method is when you have your resources, the resources you provisioned, they come and pull a server, which is like an infra as code management server, and ask it if there are changes in the environment that this agent should apply to this resource, basically. So your resources come and pull this data and try to compensate to be in the desired state. A push method, basically you deployed your resources, so they are there. But when you change your state, basically something from outside comes and check the states of all the resources, comparing with the desired states and proposing compensating actions. So this one is the one that Terraform uses, the push method. I put a table here with some tools just for you to have as an example. So Terraform uses the push method and the declarative approach. So you say, I want 2 EC2 instances for a gig, then you provision them, and the instances themselves, they do not keep pulling for new information. They are just there. So you need to rerun your Terraform commands deployment for comparing the desired state, the new state, right, with the actual one in the environment. Yeah, all good up to now? Any questions? Okay.
All those tools are open source and free to?
Yes, yes. Terraform, talked about Terraform specifically, right? Yes, it is open source. Of course, they have a solution called Terraform Enterprise, where they can, where you buy basically a Terraform Enterprise server. So it has a nice portal where it's a cluster that can manage the deployment for you. It has enterprise support plans, professional services included. So that's the way they make money. That's correct. But you can use Terraform, the tool for writing infra code, planning and provisioning. You can use it. It's open source.
Just one question. Since we were talking about around AWS only, was there any reason for selecting Terraform over CloudFormation?
That's a good question. Yes. We thought about CloudFormation. In fact, Kiko and Kyle, they have more experience with Terraform than me. Currently, I'm using CloudFormation, in fact, in this customer, NAB Bank. And It's a matter of strategy, I think, and architecture as well. For example, this bank intends to be multi-cloud, so deploy in Azure or AWS, and they want the teams to basically be able to do this transition if necessary. With Terraform, which is an agnostic tool, I mean, you'll have several providers you may have for AWS, Google, Azure. You have this flexibility, you have this option. Your team is already skilled in the HCL language, which is the language you use for describing resources. So they can just leverage this knowledge and or write new stuff, basically, for other providers, for even other targets. I'm going to show you, for example, we use Terraform for provisioning the GitHub teams that we have in the DevOps Academy. So we are writing infra as code for github.com.
You have a provider to order pizza at Domino's as well. So Terraform can be used for multiple purposes. So.
Yeah, and all of them using the same syntax. Of course, each provider will have its own resources and data sources, but you have this flexibility. When you talk about CloudFormation, yeah, it's supported by AWS, so you have support from AWS if anything happens, if your team needs help. When a service is released, usually they include this in CloudFormation as well. But if you've been using CloudFormation SAM, for example, which is the serverless extension for it, you might notice that new services, they have a little delay to be available in CloudFormation. So it depends on the strategy, right? If you want more flexibility, I think Terraform is a better tool. And using it, I really like how quick it runs, because it's just calling APIs behind the scenes. So that's why it integrates with these amounts of providers.
To add one more point, I think Terraform learning curve is much lower than the CloudFormation as well. For me, it's much easier to understand Terraform than CloudFormation.
Totally agree. Yes. And so anything that writes that has REST APIs, you can write a provider for it. Even if you build your own system, if you want to come up with your provider, you can. Then you can use Terraform for provisioning it. So this discussion, there are more to it, of course. So let's get it on in the channel if you want to know more, or that would be cool to have this discussion there. Okay, so Terraform as a tool, right? HashiCorp has many products used by enterprises, Vault, Console, and Terraform is one of them that's very well adopted in the market. So Declarative Model and push method, as mentioned. And here you have an idea how it works. Basically, you have your code here defined in files with extension TF. You have other supporting files like tvars, and .state. This is an important one. We are going to mention that. But basically, it will create a graph of your resources. So it will get everything you're trying to build, like EC2 instance. It will be in a subnet A inside a VPC X with an elastic IP, and there will be a NAT gateway attached to my VPC, let's suppose. So you can write all of it. It will build a graph, basically associating the resources, which resource depends on which resource. And it will start after doing this check, it will output to you what are the changes. And when you confirm that you want to provision it, it will start calling APIs for this provisioner, right? And well, after creating these resources for each provider and each resource, you have an unique ID created by these backends. These backends I'm talking about, of course, in our case is AWS. I'm just keeping it generic. It's called provider in the context of Terraform. So I'm going to use provider. So for each provider, you have this resource with a unique ID. What do you think is the unique ID for an EC2 instance?
ARN.
That's true.
ARN of it.
Which contain, yeah, that's correct. Which contains the EC2 ID, I believe.
Yeah, it has a bunch of other things as well.
Yeah, the region and the account. That's for AWS. So basically Terraform will store this provisioned infra in a file called Terraform state. It can have any name, in fact, but it's a .state file. So I'm going to show you in a minute. I think I can do that right now, just to not keeping this too theoretical. So let me show you some code, right? So look at this here. I'm going to delete this folder. So I have a flat folder here with several TF files and one TF vars file. Here in this sc3.tf file, I'm describing my resources. So the first thing you can notice here is resource, resource. If I choose another file, you'll see again resource, right? And variables, you may have variables too. So every TF file will describe a number of resources mainly. It may have variables as well and data sources we are going to see in a minute. But take a look at this. I'm describing a new resource, which is in AWS S3 bucket. I'm calling it internally bucket. It's not a good name. Let me put bucket name 1, 2, 3. It's not too much better, but this is an internal reference in Terraform for me and for the state file. It's not actually going to be in the AWS resource. Then I start describing the properties this bucket needs. So basically I'm passing here the bucket name. And here I'm using variables, but this could be as simple as my bucket name 1, for example. There's another property here, ACL, tags. You already know tags, right? You've done this using AWS CLI. So there are a bunch of things I'm omitting here because not all of them are mandatory, right? So the one takeaway that I'd like for you to get, and there's no way to knowing all of this by heart, is if you know AWS or any other cloud provider has a service or a resource, just come here, Google Terraform S3 AWS. Probably you'll find it in the first result. Jump here, you see, okay, this is a resource. It's not a data source. A data source is just a read structure for reading data from your provider. You can read all the availability zones, for example, just to differentiate them. You can check here. This is the example. But if I keep scrolling down, look at this. I can do more complex stuff. I can set up a website. I can set up course rules, versioning. And here, if you scroll down, there's a full list of everything you can set for a resource. So this is called argument reference. And if you keep scrolling down, you'll find an attributes reference. Basically, attributes reference are the outputs. After creating these S3 buckets, what can I query in this resource, basically? So after setting up to be a website, I can come here and get the website endpoint. Let's do a quick another exercise here. Terraform EC2. Okay, I found here, there is a resource called AWS instance. And when you look at it, this is just an example. You can consider this for a moment. You can check here, I have a new instance. I'm calling it web. AMI, I'm passing here as a variable, right? Between brackets. Instance type and tags. So if I just get this exactly how it is here and just configure my provider, I can run it and get this instance done. So let's do this exercise with the first example. Maybe I'm jumping some steps. Let me know. Are you cool? Yeah.
Quick question, Dennis. So say if we have a VPC subnet and an EC2, when I define them, does it know it should create the VPC first, and then in the VPC it should create the subnet and likewise? Or should I have to specify that, hey, first create the VPC and then go to this one and then go to this one?
Yeah, usually it builds up the graph, so it can correlate the dependencies for the resources.
Okay.
But you can use something called, where is it?
Depends or something like that.
Yeah.
Yeah. It works 99% of the time. Terraform will be smart enough to create the resource in order.
Okay.
Sometimes it will do something a little bit trickier that it won't know, like it's not his fault, it just won't know. And then you need to put the depends on.
So it's pretty much like CloudFormation.
Yes.
Okay.
Yes, in this sense, yes. Take a look at this example. This EC2, for some reason, depends on this S3 bucket, maybe because you're running something on your user data that will try to write to this S3 bucket. So there's no direct connection between these two resources, right? But logically, the way your infra is working, it does have a dependency. So you can specify that this way.
And the other thing is those three, let's say VPC, subnet, and the EC2, when I go to, let's say, AWS, is there one place that I can go and look at all these guys that are related? Like in CloudFormation, I can go to the stack and see what's in there, all the resources. In the same way, can I do the same thing with Terraform?
I know there's a command.
One place where I can look at all the things that I deployed from this Terraform stack.
You can do a Terraform state list, LS, and then it will show, but not on AWS, right? Because it's not a tool from AWS. It's just local where you have access to your states. So Dennis will go through the example. Once you run the stack for the first time, as he's running locally, it will generate a text file, which has your resource that was created. And then do a Terraform state list, and then it will show the resource created.
Let me run this simple example. I'd like to try Terraform graph as well. It's supposed to output the graph for you. So let me just do one thing first. I'd like to go back here. I lost my class in this. I'd like just to go through the concepts with you first, and we can understand better what's happening behind the scenes, because there's not much to it. But depending on what you do, it can grow, right? So you need to restructure it. So let's go through the basic commands, then we get to the demo. So what I'm about to show you is basically the Terraform CLI. So you install this in the pre-class exercise already. And there are these main 4 commands you need for using Terraform. You need to initialize the Terraform directory. This is going to basically download all dependencies for the providers. So a provider has some source code they need to, you need to download to basically call the APIs behind the scenes. So when you initialize, it will create a new folder with the provider and anything else needed. Terraform plan, it doesn't write anything to the provider, the target system, but it will show you what's planned to be deployed, basically. It's going to compare your actual state with your desired state, and will show you resource by resource what it's going to be deleted, what's going to be added, and what stays the same, basically. So we use this for validating if we're doing the right thing before calling Terraform apply. Terraform apply is going to get basically that plan and apply it, calling the APIs to provision. And the last one here is Terraform destroy. It's going to read the actual state and do the compensating actions to remove the resources you provisioned. We're going to do all of them. So providers, as I mentioned, you may have several. AWS is one of them. Google, GCP is another. GitHub.com is one. There's a marketplace in the Terraform website. You can find several providers. You can play with it. And the way we describe a provider is basically using this provider keyword, then the name of the provider, and here the attributes for the provider go. So version is very important for not, breaking the environment. So use a fixed version, preferably. And this is the version of the provider that Terraform will download. For AWS, we have this region attribute. So I wonder, for example, for Azure, probably, I don't know, probably there's a subscription or something of sorts that you can pass here. You can pass here for AWS credentials or profiles. Well, if you need to find out more, you already know, Terraform provider AWS, and you find all the configuration options you have around AWS provider. So authentication using static credentials, pretty similar to what we've done in the command line, but here as configuration, the provider. As you can see, you can use environment variables still and so on. This is all AWS specific. If you check another provider, it will be different, right? So Terraform resources are the actual resources you're deploying. Well, there's not much to it. It depends on what you are deploying. You need to check the properties, what is needed. Terraform won't ask you more than you need to pass via CLI or via console. So as you can see here, for an EC2 instance, I'm just passing information that I would pass anyway if I was calling it using AWS CLI or the console. So this is part of the beauty of it. It's clean, it's easy to read, and then you can insert variables here, of course, to make it more reusable, but still it's very clear to read. It's an example here of output. You remember when we check it, the resource, and down there, scrolling down, there was the reference.
The attributes.
The attributes for the outputs, right? So in this example we have here, we have an EC2 instance. We are asking for elastic IP, and we are associating this IP with that instance. And for that, we are using references, right? Because you don't know the instance ID, you don't know the allocation ID for the elastic IP. So we are using the outputs of these resources to configure other resources. This is where the dependency graph starts to build up. And it doesn't matter the order you write those. You could write the association first, the IP in the middle, and the instance after that, because Terraform will build the graph anyway, and will check what needs to be built first, unless you need to use depends on, right? So what's the output when I build, when I do an elastic IP, right? Not the association. I'd like to check the elastic IP. Elastic IP. Sorry, this is the data source. Yeah, so elastic IP, an example, arguments, and attributes. So you have this information to be used, right? So the next thing is basically you check what you need. In this case, we just need the allocation ID, which is the reference ID of the elastic IP. And in a similar way, the instance ID, which is your instance and the ID. But have a look at this variable we are using. This is exactly the internal name we use in Terraform. And remember that this name can be anything because it's just the way you're managing your infra code. It's not actually being deployed. So any reference that's semantic to your team that everybody can understand, you can use here. So I'm pointing to an AWS instance, which is the resource type, and this cannot change, right? Because this is the resource type, this and this one, and this is the name of the resource you gave. So resource type, resource name, and your attribute reference. And that's it. This is associating elastic IP to an EC2 instance, and it's bringing up the instance. And for the states, I'd like to do the demo. So let's jump into the console. Okay, as you can see, I don't have any other folders here for now. I'll only have here my backends. We're going to check that in a minute. But basically backend is where the state file lives. We have the provider here. I'm using AWS, this region, Sydney, and I'm using this profile as credentials. I have a file with variables. We're getting to that in a minute, but basically you may have several files with variables, and you can pass these files to your Terraform commands, so you can make things more dynamic. In terms of resources, there are some built-in resources like this one random string, which does exactly what the name is. It's going to generate a random string with 8 characters, no uppercase and no special characters. Then I have an S3 bucket, random name that I chose, with this name in AWS. And let me just undo that to use the variable so you can see it. So it's going to use that variable we are going to pass as this variables file. And it's going to use the output of this random string I'm generating. Well, just because S3 buckets needs to be unique globally, right? You know, so this is a common practice. What else? We have here an AWS security group as well, ingress 443, decider blocks and tags. And we are declaring variables. So now, correct me if I'm wrong, Kyle and Kiko, but when you point your, when you say to Terraform, you're going to use this folder here as the target folder, as your working directory, it's going to analyze all the files in it from the root module. We are going to touch on modules. So,
all files.
Sorry?
All the .tf files.
All the .tf files, yeah. Well mentioned, yeah. So if I just do something like this, I copy it from one file and paste it in another. So this one, oops, this one now is empty. The result will be the same.
It doesn't matter if you have 1 or 10 files, the result will be the same. It's just for making it easier to separate and visualize. It's like,
yeah, so that's it. So it depends on how your team wants to organize it. And of course, a bit of good sense of maintainability, because you don't really want a TF file with 500 lines if you can break it down and make it easier for other people to understand. So I'm going to go ahead.
If you guys have seen that Dennis has 2 files with an underscore on the name, that's still the same case. It doesn't matter. It could be whatever name you put .tf. It will be, it's independent if it's just 1 or 10 files. This is just best practice. Then
keep on the top to be more related to the provider and backend itself.
Yeah, I'm going to touch on this structure. So I'm going to initialize here this folder. I'm in the same folder that I just showed you, right? I'm going to do an Terraform init. Optionally, you can pass the working directory as a parameter, Terraform init plus folder name. Okay. Terraform has initialized. There are some warnings about versions. So let's go to the next one. So it's initialized. You can notice now there's a .terraform folder. Usually you don't want to version this. because it's it basically has references, SHAs of these dependencies. And if you're using the same version always, you don't need to store it. Then Terraform plan. Let's see what Terraform says if I have my AWS credentials, right? Because what's going to happen here? It's going to compare the actual environment there in my AWS account with what I defined. So if I don't have valid credentials here, it will fail. Let's see.
Can you go back to your Visual Studio Code quickly, Dennis?
Well, I duplicated.
So the two files that it's on under the .terraform. So you have it when Dennis ran the Terraform init, it created the .terraform, which usually we will do a git ignore. We don't need to commit that as he mentioned. And then it downloaded two files, the Terraform provider random and the Terraform provider AWS. So the provider, it's a binary that actually downloads. The AWS one is quite big as well. I think it has more than 300 megs. I think it's around 500 megs. It's quite big. And Terraform is developed in Golang. It's open source. You guys can contribute to that. It pretty much just Golang using AWS API calls behind the scenes. And then every time that you do a Terraform init, it will go and check, see if there is a new version, or you could have pinned one version. But if you haven't pinned, like just only use that version, we'll go and check if there is a new one. We'll download that .terraform/plugins. The same when we do modules later in the class, you will go and download all your dependencies to run your Terraform code.
Yeah, and you're right, Kyle. Look at that, 181 megs.
Yeah, not quite 500, but it's still big.
No, but it's something you don't want your version in Git. So yeah, just an example. I received an error here, as you can see. Oops, let me run again, Terraform plan. So it's saying duplicated resource, AWS security group, configuration, and it gives me basically the resource name. So when I said you can come up with any name here, that's true, but they need to be unique, basically. Because for Terraform, this is a reference, an internal reference. And when you're using as a dependency between resources, right? Using the output, it needs to uniquely identify this. So in my copy and paste fun here, I forgot this. Okay, so let's run it again. So something was wrong with my initialization here. Okay, all good. Terraform plan. Well, now we get to the variables session. So as I defined in one or multiple of my TF files a variable, it's basically asking me the value of this variable. It's like the parameters you pass in CloudFormation. As I didn't pass any variables file, neither other form of input, and Terraform has several. I'm going to show you. It's basically asking. So I can say here buckets 1. Okay, my AWS credentials are still valid, because if not, it would fail here. So this is the output of the plan command. It's saying with the green plus sign here, you can see it's going to add these S3 buckets. Some attributes it will know just after applying. It will apply default for you. So security group is going to be created. the random string as well. And that's it. It's going to create, so 3 resources. There are 0 changes and 0 destroys. So for applying this, I can either run Terraform apply, then it will check again the environment as it just did for Terraform plan and apply it. Or I can come back in my plan command and say, output this plan to a file, Dennis plan, for example. It's going to run plan again, but this time it's going to create a file. And in the Terraform apply, you can pass this file as the plan you agreed to execute. Just for not having surprises if you're taking too long to apply a change and you planned before, you agreed with that plan, but let's suppose it depended on someone's approval that took 6 hours and your environment changed it. So you don't really know now what's the plan, right? So now I can come here and say, apply this plan. I don't think my bucket name is unique. As you can see, several things are validated, but most of them are static analysis. So a unique bucket name is a thing checked only when you apply. And you could see an error here if it was not unique. Well, it was unique. So 3 resources added, 0 changes, 0 destroyed. And it took, I don't know, I didn't time it, but seconds. Let's check here if my bucket's there.
It's 4 seconds. The creation complete after 4 seconds. So
where is it?
A little bit up. Creation complete after 4 seconds. ID equals in the white letter, bold white letter.
Okay, for each resource, right? Yeah. Yeah.
If you change the plan after creating it, like if you tweak it manually, will it take, or do you have to recreate the plan? I mean, like if you, because you said that you can apply the plan after creating it, but then if someone changes the plan manually, I don't know, to screw up, will it take it, or you have to recreate the plan?
It's a binary.
Yeah, I don't think you can really edit the plan. I don't know if it's a TF file. I think it's a binary. It's not even showing here.
Oh, okay. It's quite secure.
That is just locally, right? It doesn't. It's different from AWS. So if sorry, somehow you find a way to edit that plan and apply it, and your environment is not compatible or expecting the change that you've done, you probably will just get errors coming from Terraform.
Yeah, but
yeah, that makes sense. Thank you.
But if you're actively testing and you want to apply your latest changes right away, you can just run apply, because it will plan before applying. So you can come apply.
Yeah, it's not recommended for a production environment, please.
It's not recommended for production.
In database being deleted with that approach, so yeah, not good.
Yeah, always use the out here, save your plan. And this is going to happen in your pipeline anyway, right? Nobody's going to have manual access or should edit this file. So unless they really want to tamper it.
You can do a Terraform show on the plan. I think it outputs what is there.
The plan?
No, Terraform show and then the name of the plan. Dennis plan, is it?
Dennis plan, I think I renamed it GTF. No, it's not getting.
Then do a dash JSON.
Man, this is crazy. What did I do with my plan? Let me create another plan. Doesn't take long. Okay. Okay. Okay, opening new terminal.
You need to delete that TF file because remember what you just teach? It considers all your TF files under your folder.
Or just remove the .tf.
Okay. Well, the bucket name is different now. So you're going to see the comparison of the actual AWS account resource with what I just defined. So what is the plan now? You can see here that a change in the bucket name, it leads to a replacement of the resource. So Terraform will always, well, it will try at least to tell you if it's going to force replace the resource or if it's going just to update it in place. For example, if I'm adding just a new tag here, you don't need to destroy the resource for that. But changing a bucket name, of course, you need to do a forced replacement. The same goes for AMIs in EC2 instances. If you're changing the AMI, there's no way but recreating the instance. So I have my plan here. Let me try now Terraform show. Plan 1. Yeah. So new resource required, this bucket. And I believe these integration marks, they mean that there are no changes in the resources, right, Kiko? Okay.
I never used this plan with the file, to be honest. Show plan, so I'm not sure, Dennis.
It's like a summary, right?
Yeah.
Yeah. Let's check the Terraform graph to see if I answer the question. So, well, there's not much hierarchy in this graph, right? But here you have this output, which has a root, and I believe some kind of tool can ingest this output and create a nice graph image for you. Well, let me get back. If not, any question up to this point?
If we talk about logs, like what are the logs, what is happening in the backend, if we want to see in Terraform, this is the way how we see it.
Yes, I believe there's a -- debug. Let's see. Yeah, there's a debug here. Let me try it.
Like if there are multiple resources and it ran to a point and after that it did not run further. So that would be shown here.
Yeah, this the regular Terraform apply will tell you.
Okay.
So it will show starting this operation done, starting this operation done. Up to the point you get an error, then it stops there. It doesn't do automatic rollbacks. It won't roll back so what was created, but it won't go further than that because as it is a dependence graph, right? So there's no way of going forward if you're running everything in a working directory altogether. So but about the debug logs as seen the AWS APIs, I think we can pass. Let me try it.
Maybe check after, Dennis, otherwise we're gonna run
out
of time.
Yeah. I don't know if this is valid. No, it is not. I can check that for you. I send in the...
There is a verbose command, but I don't remember which one is.
there is no rollback means that if there are 4 resources and if just 2 of them ran, that those 2 of them will keep on running. They don't roll back even if the plan fails altogether.
Yes.
Okay.
This is a point of discussion because you get kind of this for free when using CloudFormation.
Yeah, CloudFormation, it rolls back everything, I think.
Yes, not for every operation, but for 95%, you get it.
I personally prefer the half-cooked results.
Yeah, thank you.
Sometimes it takes more time rolling back to just apply again.
Yeah, I'm going to pass now the variables file to fill this variable that we have here, bucket name, without typing it. So this is where we start to think about automation a bit. So let's run again Terraform plan. This time, well, out plan 2 and var file. We just passed a file name called class.tf first. So now it's not going to ask me about the value for the bucket name, and I don't have credentials anymore.
The flow with Terraform until you get it right is essentially you run your code, you might get a few results created, a few will fail, and then you fix those, you run again until you get a plan that there is no change to be made. Then you know that you got everything deployed. This is when it's in development, right? Until you get it right.
Yeah. So as you can see, I just passed the environment, the variable files, and it worked. There's another useful way I'd like to mention using environment variables. So any environment variable that you export using tf_var _ the name of the variable, which I don't remember, bucket _ name, it will be picked up by Terraform. Of course, there's a precedence in these inputs, right? So what you pass via CLI, what you pass as a TF var file, and what you have in the environment as an environment variable. But this is useful when you're working with make files, for example, and you're passing these variables to a container, and you need to consume them there for running Terraform plan, for example. So keep that in mind that you also have this option to use, right? It is documented here. So let me go back to show you.
A good example of that is if you want to run your code of the container that it then is sent. For example, if you want to run Terraform into a container and you want to deploy something to AWS, you have to configure your container to deploy to AWS. You have to set up the AWS secret key and access, the secret and the key on the container. So it's a very good usage for environmental variables to use the make file to pass the variables to inside the container, and then the container will be authenticated to AWS to be able to create the resource.
Yeah. And okay, so Terraform state, I didn't show you the actual file, right? So let's get back. We have a version deployed. We know that. And it generated this terraform.tf state file for us. So you can see in this file, it's, oops, not this one, this one. You can see in this file, it has some metadata about the execution. But for every resource, you have details on it here. So when Terraform checks the state of the remote environment, basically it's refreshing this state, then comparing it with the desired state you mentioned. And here you have, well, everything about the S3 bucket we just created. Even the default values that I didn't specify, you can find them here, right? So someone asked it, right? What happens if I lose my TF state file? Well, if you lose your TF state file, and I believe that's a big problem, but there are ways of refreshing these states. Sorry?
I think you should delete it for demonstration purposes.
Just delete it. Okay, if I delete it completely, you know what is going to happen? What are your guess?
Can you? No, I can't.
It's just gonna, if you delete, it's gonna
look at it.
It's not gonna find. Yeah, it's gonna recreate.
If I delete, I don't have anything. So the state file is basically what you have independently of what's actually running in the remote system. So basically, I just deleted all of my references of resources I created in AWS, and later I'll need to remember to go there and delete this.
It lose pretty much all the management over those resources through Terraform, pretty much, unless you have the options to import those resources. And it shouldn't be a problem for this case, but imagine if you have 200 resources, 500 resources. So yeah, just be very careful with this file. Is the most important file of all Terraform environment, pretty much.
Yes.
Should we start this file on Git?
No.
No. Anywhere?
So yeah, that's the points I was getting at. I'm using a backend called the local. So what are backends? It's basically the location or the mechanism you're using for managing your Terraform state file. As you saw, it's very important. So you need to version it, you need to keep it safe. So minimum privileges on it, because it's basically the tracking of your environment. As I'm using a backend called local, and again, all the exercise, come here, Terraform, backends. You have a number of options. So backends, you can see, they're not all here. Okay. But here you can see you have, for example, S3 as a backend. You have Azure RM. For example, S3 is a commonly used one. So instead of local, I can specify a bucket with versioning, with minimum privileges, which will hold my Terraform state. And when checking for state, Terraform will read from this bucket for doing the plan. Right.
Yeah, and a good reason to not have that in Git is because some of the resources have passwords related to that, right? So if you put an RDS instance, a database instance, that database has a password, and these will be stored in the TF state file.
Oh,
so it's not a good, it's not a good strategy to store those things in Git.
Oh, good.
It's also not really good when you're working in a team, because every time that you do a plan and apply, some Terraform will change the order of the resource in the state file. It doesn't necessarily just like append a new resource to the end. It switched the order a few times. So if we both clone the repository, do some change, and try to do a merge request, don't ever try to do a merge conflict on a state file. It won't work. It will. Yeah.
Yeah. So it's not a thing to be taken letter by letter as you do with source code. So deal with it as you would with a binary. The Don't change it manually. Try not to. Store in a safe location, apply versioning. And yeah. Well, I'll leave it to you. There's the import feature here. As Kiko mentioned, I could go to my AWS account now, get my S3 bucket name that I have there, my ARN, right? And import this S3 bucket so Terraform sees it as if it was already created, instead of retrying to create as you saw in the plan.
It's not all resource that you can import, so it's a good strategy for recovering, but it's not 100% guarantee.
Yeah. Okay, so I think I'm running out of time, so I'm just going to skip these input variables because we've seen this TF vars, manual variables, and environment variables as input variables. There are references and examples here. You can pass in the command line as this as well. Data sources, as I mentioned before, when you come to a resource here in the Terraform documentation, which is very good, you can find for every service, almost always two groups, resources and data sources. Data source is everything you can read to reuse output. It's not actually creating anything, but helping you to create these things. So let's have a look at the number of data sources we have here. Let's have a look at AWS AMI. So AMI is the image ID, right? For spinning up EC2 instances, for example. With this data source, you can say, look for AMIs, which the owner is myself, with this name regex, filtering by these properties here. And you can say, return just the most recent one, just for not getting an array, right? And this will, as resources do, this will output some data for you so you can reuse, for example, when creating your resource EC2 instance. So there's an example. I'll quickly show you here. I won't run it. And it's one of the exercises, pay attention. Spoiler. So here I'm using the AMI data source for doing a quick filtering. And I'm using later in my AWS instance, the output of that data source. As you can see, the syntax is a bit different. You need to start with data, dot, then the data source type, data source name, and the target attribute you want to get, right? And I'd like to mention, just for you not to get lost with it when doing the exercises, this pattern data dot is for data sources. If you're pointing to a variable, var dot, right? External variables, when I mean variables in the context of Terraform, because you might still have local variables. And for local variables, you use local dots. So just keep that in mind. It's not a hard syntax or anything, but when there's data dots, you know it's coming from a data source. Var, an input variable that came somehow to this execution plan. And local, probably something declared in the same file. So just look for it, you'll find it. Okay, data sources. And finally, outputs. Outputs are very simple. Basically, when the plan finishes, or the apply finishes, sorry, not the plan. When the apply finishes, you can output some of the data that you didn't have before. For instance, the private IP of an AWS instance, EC2 instance. You can just declare output, the name of the output. Then you just reference the resource as you would when using for any other resource, right? Just pointing to an output, and you set the value attribute. And it just shows nicely for you when you execute it. So I said I wouldn't execute it, but as I'm here, let's see how it goes. It won't take much. I'll go directly to apply. Okay, 10 resources to be added. VPC, subnet. So remember all of this work you did, put some love in it. Think now there's a better way of doing that. So think about everything you've done. Now it's all here. Just come and confirm, or you can pass a flag auto approve. So it will run straight away like a force. And after executing, you can see subnets being created, internet gateway, private and public subnets, right? Route tables. Now my instance is being created using one of the subnets.
Who wants to redo this using the AWS CLI one more time?
And as you can see here, we have the private IP, which is an output. So if I come here, outputs, usually declare it in a separate file. There it is. And here you can see it. And more than that, with Terraform output, you can get it and automate it using it. So I like how fast it is. If you were running the same thing in CloudFormation, it takes more time. I know it's just a matter of minutes, but when you're experimenting and you're going fast with something, you really want this kind of agility. Yeah, let me go back. We need to go to the project. So let me check if I'm done.
Quick question.
Yeah.
Can you use multiple providers in the same deployment?
Well, that's a good one. I know you can use multiple providers. When you're copying from AWS to Google, GCP, for example, you'll need credentials from both providers, right?
Cool, thanks.
And there's a way of using aliases with providers. You can give a nice name, and in your modules, you can just change the provider as you need them. So the last bit is actually about this, is actually about organizing your repo with this good practice, putting underscores on special files like backends, variables, outputs, and provider. These are special Terraform files. The rest is all resources, right? And more than that, there's an important concept of modules in Terraform. If you need to scale if your infra is kind of big, So let's suppose in the project you have to use like ECS, you have service, task definition, but besides that, maybe you run using EC2 instances, you need a subnet, VPC subnets, route tables, internet gateway, a bunch of stuff. So would you do all of this in a single folder, in a single flat structure? Or even more, if you're reusing some stuff, let's suppose security groups, you're creating security groups in a special way. And you need to create, I don't know, 20 security groups for the project. So instead of duplicating codes, Control-C, Control-V, Control-C, Control-V, just changing the names, you can create a module, which basically is a reusable resource or set of resources, and you pass variables to this module, and it becomes reusable. Basically, it has inputs, resources, and outputs, as you already know. But you can reference them just using module, the name of the module here. Then you pass the path, which is the folder usually. It can be another GitHub, it can be a repository as well, but usually it's just a relative path. And then you pass the input you need. These are just an example, but I could create a module for creating S3 buckets, for example. I need all my buckets encrypted. I need all my buckets with a specific bucket policy. Instead of doing Control-C, Control-V in every place that I need to create a bucket this way, I can create a module, secure S3 bucket, and here I just pass name, the source, right, of my module, the name of my bucket, KMS key ID for encrypting, for example, and so on, whatever I need, right? So have a look at that. We won't have time to dig into it, but have a look at modules.
One of the
you might
exercises
need or not in your project. Sorry, Kiko.
One of the exercises is related to modules, so they have this hands-on, which is good.
One last way of doing vars with Terraform, if all of the ways that Dennis showed is not enough, is if you have any files named like anything.auto.tfvars, if it is auto.tfvars, anything before that, anything appended to that, it will just load. You don't need to specify any command line or anything. It will just load the values from there. It's useful when you are using the same files for different stacks in different environments, and you need different values. And you have the same value for all the stacks to be used.
Yeah, and you have all of these in this document. I really like Terraform documentation. Yep. It's very straightforward. The tutorials are pretty good, so just follow it. And here you have all the ways of declaring variables, using environment variables and anything.
What is the biggest pitfall in your eyes when you're using Terraform? Into really big, yeah, losing the state file, yes, yeah, but
I'm okay with that. I think the language itself, the HCL, it's not really. It's much better with the Terraform, the newer version 0.12. It starts to get complex when you have, for example, as Danny said, 20 security groups. Like you need to do like for loops and those kind of things to not repeat code. And then you start to get some complex scenarios that the language doesn't help much. It's not a development language, it's not a programming language. So it has some limitations on that. But then I guess CloudFormation also will have, any other IAC will have those sorts of limitations.
So will it get to a point where you might think like, hey, CDK is much better in that sense when it comes to that point?
Yeah, I don't know yet. The state file, there is ways of protecting that, like using the S3 buckets. Then you can have, forgot the word.
Versioning,
yeah, backup. And then it also uses the solution for AWS is S3 to save the file itself on S3. And you have a DynamoDB table to control the locking, because Terraform, once someone is using a stack, it gets locked to avoid people of two people to committing things to the same file at the same time. So you can use a DynamoDB to lock that, and if someone is applying something, it won't allow someone else to run plan apply at the same time. So it has some, I don't know. I really like Terraform, to be honest, for the IAC tools available these days.
I was concerned with the Terraform state file at the beginning, but I got it that if you have a good process and you do it the right way, you won't have many problems with it. So it works fine unless you mess with the file, you lose the file, but then it's the same care you need to handle any data in a customer system, right? So you need to take care of that. And last thing, and it's important, Terraform destroy to remove all of your resources created. I just sent in the chat if you're curious about our scripts. That's going to destroy everything. Yes. How we do with github.com and Terraform. So you can open there. It's in the Academy repo. So if you're wondering how we create projects and things like that, you can see there. So it's destructing everything. Yeah, done, destroyed. So let's move on to the project. Are you presenting, Kyle? Or
I think Kiko, he have done the groups.
Yeah, I can do it. It's fine.
All right, I'll stop sharing here.
Yep.
I'm sorry I said that there was no exercise for this class, but it's because we moved the Terraform class. We pull it forward. It wasn't supposed to be on this class. And well, it was supposed to be on the last class. We did it on the third class, last group, and it has a few, but it's not much.
So you have the project and exercises.
Yeah, but it's not that bad.
But now we can use Terraform for instead of AWS.
Yeah. The power.
Yeah. In regards to the project, guys, we have this first project, which is application migration from, let's say, an on-prem to the cloud. It's very similar to some of the work that we have done in the past, like migrating apps into the cloud. You guys are going to be split into 3 groups, and those groups are already defined. We created 3 like channels when we're going to jump and put you guys into those groups after the class. And basically, this is just to this project. What you guys are going to do is just pretty much deploy a LAMP stack into AWS. A LAMP stack is just a Linux, Apache, MySQL, and PHP, which is going to be an application called WordPress. I believe some of you already played and knows about WordPress. And this is going to be running over a container in ECS, right? So we have a few requirements for this project here, and you guys then can read through these later and talk between each other how you're going to tackle these. I'll show the project later, but basically containerize the application using Docker. The application needs to be secure and high available, needs to be scalable, and the infrastructure needs to be controlled through version Git So pretty much doing through Terraform. Hopefully you guys won't do CLI.
Unfortunately, we don't accept CLI. Yeah, sorry.
Yeah. And it needs to be a fast way for deploying and with fast feedback, which is pretty much using CI/CD. This last bit will come into the next class. So you guys can pretty much work all the rest up to next class or part of it. Just leave the CI/CD part for after 2 weeks from now, pretty much, right? What you guys gonna do is create everything, all the code, deploy it, and you guys gonna do a presentation on class 6. So in 4 weeks from now, you guys gonna be presenting that to us. Each group will do their own presentation. 10 minutes for demonstration and 10 minutes of questions that we're gonna do during the presentation. And just a few things that you guys need to provide during this presentation, pretty much a solution diagram of the architecture of the solution, how you guys are making the life of the developer easier when they want to deploy new stuff. Let's say that it's a CI/CD process, so they'll be doing updates in the Git repository, commits there, and this needs to flow into a production environment. So how you guys tackle this problem, let's say this way. How is the monitoring of the system and how the system handles failures? And just list some improvements that you guys think would be nice to have in this application. And this can be done through a README file in the repository that you guys are gonna create. I think that's pretty much it as a general idea. We have some recommendations of technologies here. Just in pipeline tools, and we need to upgrade that it's a failure on our side. We're gonna pretty much use GitHub Actions. You guys can use different tools, but we're gonna be doing a class on GitHub Actions. So ideally you guys are gonna use that. For the rest, GitHub, Terraform, Docker, RDS, and ECS. This is just a breakdown of how you guys gonna work. Let me just jump into the project because we create 3 projects, one for each group. The projects are here. I'm just gonna jump into one of the groups. It's pretty much the same for all. And we have all the tasks, at least as an initial task here, that needs to be completed for the project. And this is just a breakdown. So each of these tasks is a piece of the code that needs to be created or the solution. I'll just open a few here just to give us an example here. If you jump into this task specifically, it has objectives and acceptance criteria. So basically the objectives will be have a new VPC with a /16 CIDR, 2/24 public subnets, 2/24 private subnets in different EZs, obviously. 2 echoes, one for public key and one for privates. Internet gateway in place, and then the acceptance criteria will be code is in Terraform and merge into master. I can run instance in public and private subnets. I can directly access the private instance from internet, and so on and so forth. Most of the cards or the tasks will have something related to README. So it's a good practice to just keep the README updated while you guys are deploying the code or creating the code, just to not have everything to be documented in the end. So we have some, let's say, reminders about that in each of those tasks. Ideally, if we jump back here, this is what we talk about in the Agile methodology. It's just a board for seeing the progression of those cards. So ideally, everything will be moved into the done column. And we go into those 3 steps in progress and a review. If you guys want to create additional columns here for blocking or anything related to some other status, feel free to create. You guys are the owners of this board, the owners of these cards. If you guys think that additional tasks needs to be created, feel free to create. This is just a basic guideline for the what we see as a requirement for the project, right? Any questions up to here, guys? Everyone's scared?
Yeah. You guys will have full access to those projects. So it's not us that will be merging pull requests and those kind of things. You will be the one that will create a merge request, pull request, and then we'll ask your peers to review your codes. And then once you're happy, you merge and so on.
Yeah, we are able, of course, to help and provide answers. If you guys have any questions, we are more than happy to support. But ideally, you guys going to be creating everything and leading the project and handling pretty much everything. Deciding if you are, I want, for example, I want to go with Fargate. Our group wants to go with EC2. So you guys are free to take those decisions. Just consider that each decision have its good things and bad things. Just make sure you guys are comfortable with what you guys are deciding. If you have any questions, feel free to jump into us, and we are more than happy to provide additional feedback. Yeah.
And one hard part of this work is communication and working together. Right? It's too much for just one person to do, because if you read the project description, there is a little bit of storytelling there. So we'll have two hats. One is the product owner hat. So each one, I don't think we decided that yet, but each one of the three groups will have one assigned person. So I'll be with one, Kyle and Kiko with theirs. So any question related to business requirements, things like that, we can solve. And the other one is the technical one, of course. So probably we'll schedule some conference calls with you just to clear up questions, but the ultimate decision is yours in the design. So we put there a business problem, basically. It's a simple one. It's a web application, a web layer talking to the database, but it needs to scale. Do you have monitoring? What about logs? What if a problem happens? If a server is down, how do I know it? So this is the kind of questions we are going to ask. And the means to solve these problems is the technology. So keep that in mind, that we don't use these tons of tools for fun too, but it's for solving a business problems. So we are trying to mix a bit and leaving the decisions with you to work as a group.
A suggestion is to, after today, maybe even this week, because it will take time. Don't leave it for last week. It takes a lot of time to go through it. A suggestion is get together with your group, book a kickoff call, and then split some of those tasks, one task to each of the persons. That's a first suggestion that I would say. Yeah, feel free to invite us to be on this kickoff call. We can answer more questions about that. And try not to go straight into the Terraform and from the scratch start creating Terraform code. First, try to do some what we call click ops, go into the console, play around with the solution, what you're trying to achieve. And once you know what you need to create on AWS, then you start coding that part of the code. And for tasks, for example, you can ask me, how come I'm going to do the ECS cluster if I don't even have a VPC? Like, I need to wait someone to first create a VPC code. You don't, like, just create for yourself, maybe put some, or use your existing VPCs there. Use like the, when you're creating the EC2 instance, if you need to pick the VPC subnets, just pick whatever it's on your AWS, don't use vars or anything. And then once the code for the VPC is ready, towards the end of the project, you guys will just merge everything together and have just one solution.
Yeah.
Something that I've seen in the previous running of that is one of the main problems that happens is communication. So I would suggest that you guys communicate pretty well. Try to schedule meetings every week, at least, to understand what everyone is struggling, how is the progress, so you guys can keep up with the requirements. And maybe just try to write every day a message. Oh, today I'm working on that. Yesterday I did that. Something similar to a stand-up meeting, because everyone will have different available times. You don't need to have a meeting every day. Just try to communicate in this Slack channel so everyone is aware of what's happening with everyone. So if you have, I won't be able to work in the solution today, let everyone know so everyone is comfortable between each other. So try to communicate as much as possible, because as Kyle said, it seems to be simple, but if you guys keep, oh, I'll do that tomorrow, I'll do that tomorrow, you guys gonna see that, you won't have time to complete everything.
I think it took me around 10 hours to complete the exercise in Terraform. It takes a long time. It's not simple.
Mm-hmm.
Well, it's simple, but takes time to go through.
Yeah, it's a simple solution, but the amount of non-functional requirements we are asking makes it...
For the external students, we will be doing one group with you guys. I just will ask you to create a thread on the public channel and put your names there with everyone that wants to go through the project. And then we will create a project for you guys. Feel free to invite us for your kickoff call as well. And we will book with you a presentation for the project as well.
Good. Yeah, you mentioned, Kyle, are we scheduling a kickoff call with them? Or
we just said that kickoff, they will organize a kickoff call and they can invite us to be, if they want to.
Right. Yeah.
Well, let's leave to them.
Don't leave to the end of the week, please. Don't leave to the end of the week. Otherwise, you guys just lost a week of work, and it's precious. Yeah. This precious.
And you own the board as well. So this is a suggestion. You'll need to go through these technical tasks, VIPC, ECR, EFS, but by all means, if you want to restructure the board after talking with our team, feel free. The board is yours.
We're gonna lock the repositories on Sunday night, right, Kyle? That's right. So we can review. Yeah, so we can review the code that you guys created during Monday. So don't leave to do updates Monday before the presentation, because you won't be allowed to do any commits there. So just make sure everything is delivered and committed on the last Sunday before the presentation.
Yeah, we'll most likely lock like Monday early early Monday morning. So just don't leave because we need time to review your code before the presentation so we can ask questions. Do you wanna go through the groups, Kiko? Sorry, guys, we have a little bit over time.
Yeah, I'm just getting here.
Anyone have any questions? Ready to jump on after the class?
Cool. So the groups, we have group 1, which is Alan, Zara, Fabio, Fernando Braga, and Mariana. Group E, Marcos, Nimi, Guilherme, Gustavo, and Chim. And group 3 is Jay, Fernando, Daniel, and Vanita. I'll just invite you guys to the channel that you guys belong if you don't hear. It's also in the Git code that we have in the Academy repository, so it's all there as well. But I'll just invite you guys to the groups, and you guys feel free to start organizing yourselves.
Another thing is don't do it by ourselves. Try to work as a group. That's one of the challenges of this exercise, is to work as a group and get dependencies from others and understand how to deal with that. I think it's a really good exercise to go through it. I think you guys will enjoy it. Do we have anything else for today?
Yeah, I think that's all.
Kiko will share the list of the groups, and we'll invite you all for the specific Slack channels. I'm pretty sure on GitHub you should already have access to your groups. And that's it. Let's jump straight into it. I think that's it then. Thank you guys again. If you have any questions, any issues, let us know in Slack. We're happy to help. Please involve us on your calls. We are here to help you guys to get through it. And we'll see you again in 2 weeks.
Thank Thank you, guys.
Thank you, guys.
Thank you.
Thanks, everybody.
Thank
Thank
you.
you, the listeners, the attendees as well.
Thank you. Thank you. Have a nice
Thank you.
Thank you.
Guys.
Excited for the project.
Yeah.
You can run the pool, Dennis?
Sorry?
Ooh,
Are you going to run the pool? The questionnaire?
Oh, forgot it.
Run it. Still have a few people online.
Okay. It's there. So quick poll, 3 questions about the presentation today.
It says hosts and panelists can't vote.
That's
oops.
strange.
Yeah, it disappeared.
Okay. Who opened the meeting, Kyle or Kiko? It wasn't me.
Not me, it was Kyle.
Can you vote?
No, it's
No.
too late.
No, okay. No.
Not yet.
No.
Go again.
Yeah.
Yep, that's
Hey.
better.
Daniel just asked us a question on the chat on Slack. What if we are excited for Terraform 13? Yeah, quite excited. It's gonna be some nice features coming in around modules. We'll be able to do for loops and depends on modules. But Terraform takes so much time to release new versions, and I don't even expect. Don't wait for those. The 0.12, there's 0.11 to 0.12. I think it took like 2 years. They keep postponing and postponing and postponing. And it's nice that it breaks everything.
You mean
That's the correct version.
so it's not backward compatible?
It is, but if you run with a newer version of Terraform, you can never run back to the previous version. So it's kind of
At least it was like that on
forward compatible.
It was big change. So I expect to be some big change on the 13 as well. They are not 1.0, right? So they have the right to break change. They can break chains because they're not full release yet. It's been around for 100 years and are not 1.0 yet.
It's like the Gmail beta.
Yeah. Just so can they break things.
Nice.
think
Should
everyone
we end the poll?
Did you take pictures, Dennis?
No.
How the
Really?
bloody Zoom thing. Cool. Thanks, guys. Thanks for that.
Thank you. That's all.
That's it. Thank you all.
Nice. Thank you.
Thank
Have a
you
good
all.
night.
Next time.
Thank you.
Have a good night. Bye.
Good
Bye-bye.
night.
Hey guys, thank you. Have a good night.
See you guys.
Yeah,
Bye.
you too.
Thank you, guys.
Thank you. Bye, guys.